Okay, let's go through the parts here. This is an Arduino in here generating three-phase TTL levels. This is my MOSFET driver board. So this is optically coupled, and then this chip is the gate driver. These gate drivers then go to the MOSFETs and drive each of the three phases, an upper and a lower, high, low, half bridges. And then I have these current monitors here. So these are Hall effect current monitors that generate a analog signal out. And these are monitored by a second Arduino, who are then plotting the results of these on the screen here. So this is my laptop who's monitoring that. So let's, if we start, oh, and then that all goes to the high current, high voltage drive goes to the motor. And right now the motor is stopped. So if you go in here and we start cranking up the RPMs, we have to get to about 3 hertz or 90 RPMs before we start seeing stuff, but we are seeing some current appearing here. And when we hit that spot, you see that the motor just starts turning, and we're drawing quite a bit of current here. This is probably like 5 or 6 amps per channel. So let's quickly get past that high current zone and move up to roughly 10 hertz here, or about 300 RPMs. And you can see the RPMs is slowly coming up, and the current is about 9 amps right now. And as we're accelerating, you can see the fluctuations. The motor is oscillating because we don't have any feedback on this. So we are just driving the motor blindly and letting the current draw. So we're driving a voltage, and the current is being determined by the motor itself. So here we are. The blue line here is the RPM. The red line here is the current that's being drawn by the motor right now. So we're about 10 hertz. Voltage waveforms, and we're seeing about 10 hertz in the RPMs that we're measuring. So we've got a quadrature encoder on the motor, and that is reading the RPMs that way. So as we go up in current, we're causing some oscillations in both the current and the RPMs, and eventually that'll stabilize because of just as the motor naturally comes up to speed. So we're now dropping in current. We're about 5 amps per channel, and we're very close to 13 or 14 hertz excitation frequencies, and you can see the motor spinning up here.